Welcome to Empower You, everyone. It's so nice to have a good crowd, good big crowd here tonight. I'm Dan Reganold, and the goal of these sessions is to educate, enjoy, engage, and that's our goal here, and to just teach you some things to help get you more empowered in your lives. So tonight we'll talk just a little bit for a few minutes about education in Ohio, and then our main session tonight is climate change. I can't wait to see the return of Dr. Frank. So, hey, listen, the funniest thing I heard today about the $1.9 trillion pork fest was from Senator John Kennedy from Louisiana, who said, calling this $1.9 trillion bill a coronavirus bill is like calling Harvey Weinstein a feminist. I hope I can say that, Jay. I hope you don't have to buzz me for that. But yeah, it's just a lot of money. Like I showed you the graphs the last time, and it will be a long time paying that back. I want to introduce you to the people that make Empower You possible, and um, and that bring you these sessions. And let me just share with you our team. We've got our great executive director, Betty Overstreet. We've got Jill Google, our operations director. We've got Bill Roll, our treasurer. Jay Grunke is our producer on the board tonight. And we've got our political director, Joe Platt, Ken Bowman, Karen Cartier, who did that. That was an incredible session on Tuesday night on organic gardening. We've got Bill Monier, Nita Thomas, and Barb Horowitz. I just spoke to Barb earlier, and I'm so happy. I had sent a note out to the board and asked the board if somebody would do kind of a beginning of a session in April about McCarthyism, because there's so much of that going on with cancel culture and stuff. And Barb has told me she's going to help us with that, and I can't wait to hear what she's got to say. So we are a free university, and we don't mind passing the hat, asking for a couple bucks to help us with production, advertising, staffing. The easiest way to donate a couple bucks is when you sign up online at Empower You, or you can just go to the right side of the website where it says donate. We just thank you. So many people have donated, and it's greatly appreciated. So tonight's giveaway is a good one. I urge you all to think about it. When we did our social media class, I've got some more things to say about that Tuesday, which I think you'll be interested in. Many people said, who do you get your news from? Who do you listen to? Well, there's 3 or 4 people I go to every day. Townhall.com is one of them. Tonight's giveaway is for a 1-year membership to townhall.com VIP. You get ad-free browsing, exclusive columns and articles, and access, the most important thing, to their VIP area of their website for 1 year. To enter to win, all you have to do is go to the bottom of your screen where it says Q&A, enter your email address, and when they're all entered, everybody who wants a chance to win, and there should be quite a few of them tonight, we'll do a little random number generator, and we'll pick one. And Jackie the other night won a great book from Janice Steen, which is on its way to her. And I hope you'll sign up for Town Hall VIP. I think it's great reading. So tonight's required reading, I want you to read if you can. By the way, Betty sent me a note today telling me that a few of our required readings weren't coming up correctly. I've changed that, so you should be able to go back to them and read those important articles. But tonight's required reading that I urge you to read is from Dennis Prager. It's entitled "Most American Schools Are Damaging Your Child." In the article, Prager says, the worst news is that sending your child to almost any elementary school or high school, public or private, is fastly becoming toxic. More and more schools are being taken over by left-wing ideologues and the non-ideologues who lack the courage to confront the ideologues. And guys, that's us. And once infected with leftism, these schools teach children to hate reason, tradition, and America. So I need to follow up. I know everybody is really eager to hear Dr. Frank. I'm just going to keep you a couple of minutes before we get started. And I need to follow up with you and talk to you for a serious minute about Ohio schools, and it's about confronting ideologues. So several weeks, an anonymous person called me on the phone when I was traveling. I'll call that person Deep Throat. They contacted me and told me about something that I was unfamiliar with called the resolution that the State School Board of Ohio had passed, called the Resolution to Condemn Racism and to Advance Equity. This is just one of those typical PC identity politics kind of thing that's circulating around governments all throughout Ohio, like Dayton, like Hamilton County. And in this resolution, it says things that you're not going to want to hear. Things like the board will indoctrinate and train employees. The board will ask for a period of reflection, and they'll ask you to take an internal examination of yourself. And in all this writing, it has the assumption that we all have implicit bias. We all are biased, regardless of what's right here. The most important thing, what's in your heart. When you read this resolution, what it looks like, it sounds like, and it feels like is critical race theory. So I started looking at this school board website. I know I've got some education people out there tonight, and I found a link to the 1619 Project. Many of you know what the 1619 Project is. It was created by the New York Times, and what it tries to do is convince people that may not have a great history background that the United States was founded in 1619, not 1776. On the State of Ohio website, there's an article from someone named Nicole Hannah Jones that tells Ohio students that the truth is that democracy has been born on the backs of Blacks. It says Blacks have seen the worst of America. There were lesson plans on this state site. There was curriculum. There was division. What there really was, there was anti-America stuff. And so I reached out on the phone. I picked up the phone, called the president of the state school board, a woman named Laura Kohler, and asked her to take the 1619 site down. I said, you've got to take this site down. This is not a factual site. You can't let teachers across Ohio teach this stuff. At first, she tried to tell me it was up on the site by mistake, that somebody who wasn't authorized to put it up had put it up. But she got back to me pretty quickly after she'd spoken to the superintendent of the Board of Education for the state, Paulo DeMario, and said that despite the fact 1619 has really been disgraced across the media, and it's factually incorrect, they were going to leave it up on the site. So after thinking about this a couple of weeks, I just made the decision that I felt like I needed to at least let our governor and a lot of our key legislators, representatives and senators know about this, know that our state school board has really been radicalized. What the board seems intent on doing is dividing students among race. So see, our founders were so clear about this. We learned just the other night, Washington and Hamilton. Washington was the people person. He could talk to anybody. Hamilton, the brains, said they both were united. We've got to be unified. We must be united. Thomas Jefferson was frantic in his dying days, working on an education project for the University of Virginia, which, by the way, he founded. And he said, we must enlighten our young people to be educated in the principles of liberty. And he said, the single principle that we must teach all of our young people is that all men are created equal, from the Declaration, which he wrote. Lincoln, after a terrible Civil War, said, we are one. I want to look you in the eye tonight, you Ohioans, and ask you, how can our country and students be unified if they are being divided by race intentionally? We need to get the school board back on the tracks before it crashes. To our guests that are from out of state tonight to hear Dr. Frank, I can pretty much tell you that this kind of stuff is happening everywhere around your area. Take heed. Someone emailed me today when they knew that I was working on this and told me the story of Beechwood Schools. That's a school system up north on the lake. On March 6th, just a few days ago, they held a mandatory critical race training at Beechwood High School for everybody. Also, the school board there quietly changed their policy, and now they give teachers the right to express their own opinions. Boy, I bet that's going to work out great for them. So you'll get a copy of my letter sent to Governor DeWine and to many other important state leaders today. I'll be sending it to you by email, and it'll also be up on our website later tonight. So I've got to ask you, I don't ask you to do things very often, but I'm going to ask you tonight to read the letter to the governor. And if you agree with it, send the email out to a couple people that you know. I'm not posting it on social media. And maybe if you get courageous, send a note to the governor and tell him you don't want this stuff for the students in Ohio to be divided by race. My interest in telling you this is simple. I want to get the information out there, and I want people in Ohio to clearly understand what's going on. Tonight, I'm just sending kind of a shot across the bow that we can't let our kids, our students, we can't let them down on really one of the most fundamental responsibilities that we have as Americans. We must be united. We must be one when it comes to these young people. Thanks. So, hey, I hope that several of you got a chance to meet one of the city of Cincinnati's newest council people the other night, and that is Steve Gooden. And Steve is really the real deal, and I really enjoyed our chance to meet with him. Hope you got a chance to see him. If you didn't, you want to see what the future of Cincinnati looks like if he can get reelected. I think it's Steve Gooden. And a big thanks to Leanne Carter and Leanne Cartier and Karen Cartier for their organic session on organic gardening. For the couple people I know in my neighborhood that are online tonight, please don't look for my garden. I'm gonna try it though. It looks fun. It looks relaxing. I hope I can grow a few things. So a couple upcoming classes before we get started. March 16th, we've got tech guru Rich Inman. He's gonna dig us just a little bit deeper into how to navigate MeWe, which is kind of a Facebook lookalike. And we've also got a new social media site, Telegraph. Now, somebody emailed me earlier this week and said, hey, what's up with Parler? When's that going to be done? Well, Parler is working for those of you who had accounts set up before they went down. So you should be able to get back into that if you want to. On Tuesday, we're also going to be discussing something very controversial, and that's the Convention of the States project. And I know you're going to want to hear both sides of it because it is kind of controversial, but I'm looking forward to having Mike Mowry, the director of Ohio for the Convention of States, in to talk to us. The Convention of States, what it represents is it represents one chance for the people, that's us, to actually win, to actually hold our government accountable. I know you don't believe that's possible, but Mike will be in on Tuesday night. This is a special start time of 6:45 p.m. for Tuesday night's class. So I urge you, if you don't know about the convention, if you're interested in me, we sign up. And then on Thursday, a week from today, Dave Hatter returns. Always great. And what we're going to be having Dave do this time, which should be fun, he'll be taking your live phone calls after he talks for a little bit about network and security. Dave is just always so great to volunteer his time and join us and come and teach us. And you'll get to talk to him that night yourself. So tonight's the night, climate change. So glad to have you all here. So I'll start off with my introduction of Dr. Frank. I'll maybe surprise him a little bit. So everything I have ever learned from Dr. Frank, I learned from duct tape and small twists of baling wire out on the farm. Let him tell you about that. Douglas Frank grew up on a small black Angus ranch in Northern California. His parents were successful entrepreneurs in the areas of insurance, investment, and real estate. And he earned a BA in chemistry from Westmont College in Santa Barbara, California in 1983. He then attended graduate school at the University of California, Santa Barbara, where he completed his doctorate requirement before transferring to the University of Cincinnati in 1986. During his graduate work, he discovered a new phenomenon, which was featured in several science books and international journals. He left academics in 1996. He specializes in the development of custom control and analytical solutions and has invented several instruments for surface optical characterization. Dr. Frank lives in Morrow and is married to his high school sweetheart, Donna. He has 3 adult children. Dr. Frank loves to give back to his community. He has worked with the Blue Ash Montgomery Rotary Club. He is one of our most popular. Dr. Frank is the chair of Math and Science Department for the Schilling School for the Gifted. And recently, he has gained so much notoriety with all of you for his modeling work of the COVID-19 pandemic, where at one point he had about 50,000 followers on Facebook before they started to get tough with him. Dr. Frank, we're so glad to have you back at Empower You. Welcome.
It's good to be here, Jay. You must have been reading my webpage today because I put up that thing about duct tape and baling wire.
I had good intel.
That's fun. Yeah, on the farm, you learn to do with what you have. You're out in the middle of the field. You don't have a chance to, walk all the way back to the shop and get a tool. You use what you got. And I don't know what it is, but there's just always baling wire around on a farm, at least when I was a boy. And then duct tape, you made sure you had a roll everywhere you could find one. So you always use that stuff.
That is my weapon of choice for sure, duct tape.
I mean, I've done surgeries on animals before and used duct tape and baling wire. It's kind of spooky, but that stuff's handy.
Well, listen, it's so good to have you back tonight.
Thank you.
You've got such a unique style of sharing data in terms of helping you reach your decision. And I just know that I've met with so many people over the years that empower you about climate change. It's just one of our most popular subjects.
Sure.
And, I just encourage people tonight, as you start to have questions about anything Dr. Frank's talking about or anything that's on your mind, just go to the Q&A section. I will, when it's timely, interject a few times,
Sure.
ask Dr. Frank questions, and let's just get into it tonight and get your questions answered. I'll let you go.
All right, so I'll share my screen here. Get this going here. Can you all see that?
Yeah.
I get this thing started here. There we go. Is that me?
Wow.
Okay, let's see. That's I have back when I had more hair. All right. So I'm supposed to be talking about climate change today. Y'all can see that. Jay, Dan, okay?
Yeah, we can.
Okay, good.
Pretty good.
All right. So I've been a PhD scientist for 40 years. As you mentioned, I made a cool scientific discovery. It kind of got me famous for a while. And I mentioned it again tonight because there's an aspect of it that is relevant to this. And then, like you mentioned, I love designing and building scientific instruments, especially if they collect lots of data. That's my favorite thing, to process lots of data and have techniques to analyze. But I got to admit, I just love teaching. I think I was born to teach. I think God made me to teach. So that's who I am. And tonight, I'm just, I need you, Dan. I've had a long day. I'm tired. I'm here to have some fun. But I could talk forever. So you're gonna have to jump in and grab at me every once in a while. Keep me on topic.
I wish I could pass you over a Diet Coke on the road, but
Right.
I'll try to keep us both revved up. And that means everybody out there, you help us too, okay?
So I have to tell you, Dan, this was the hardest presentation to put together I put together presentations all the time. This was so hard for me. And it just dawned on me today why it was so hard. I've been studying this since 1981. So I have I'm bursting with stuff I want to say. There's just no way I can get it all in one talk. So what I tried to do is, I put together all these slides. I had 150 slides when I was ready. And I figured, no way, I can't get through 150 slides. It's just not going to happen. So I went back through and I took out all the things that I think most people have already heard. And I kept the things most people probably haven't heard. And so I think that'll be fun for us. So anyway, that's how I approached it. And these are what I'm going to try to cover tonight. So I still have a big list. So we'll have some fun. There are lots of other topics you could talk about. And maybe people at the end, if we have some time for questions, they can ask the one that's particularly interesting for them. So I'm trying tonight to not be too technical. I'm trying to keep it simple and fun. I'm going to try to explain with crayons. A politician I was working with recently said, "Hey, Doug, the legislators won't understand it unless you explain it with crayons." So I'm going to try to explain a lot of this tonight with crayons. And then a politician, political advisor I was talking to the other day said, "Doug, talk to me like I'm 10 years old." So that's what I'm going to try to do tonight. I'm going to try to keep it fun and simple. The only bad thing is that after I talked to him, then he came back and he said, "Talk to me like I'm 5." So sometimes things are just technical and you have to think about them twice. So why me? Why does anybody care what I think about climate change? Well, what's funny, it's not funny, what's interesting is I've been tracking and modeling epidemics since high school, back in 1979. I've been modeling climate change since 80, 81, somewhere in there. And I've been modeling elections since 1980. Now, if you think about that, what 3 things all happened in the last year that are majorly big issues? Holy mackerel. This year has been an amazing year for me. It's everything these are my favorite things that I've been tracking for years. They've all come to a head all at once. I've been following the data on all three of these topics for 40 years practically. My son came down when we were doing COVID last year in like March or something, came down the stairs, saw me sitting in my easy chair, hammering away on the laptop. And he said, Dad, he says, you were born for this. I mean, he's exactly right. This year was like the year of Dr. Frank. I can't even believe everything came together. So, you know, I told him I was going to do this talk tonight, and he says, Dad, he says, it should be easy, Dad. He says, all you got to do is show him the data. That's all I have to do. If I just show you the data. And of course, anybody who's following my pages, that's what I always tell people, just follow the data. But sadly, it's not that simple. And you know, Dan, because you've been in politics longer than me, that it's not that simple. Being persuasive matters. And, you know, some people have been particularly persuasive. So I had a situation at my school where one of our teachers showed inconvenient truth, and half, you know, all the kids go home, and then, you know, some of you parents don't know this story. Half of the parents are very upset about it. Half of the parents are very happy about it. So the next day, you know, the director, head of school, you know, she's buried in phone calls, and she says, you know, can you help me out with this, because I got all these angry parents. Can you show the other side? And I said, I don't want to show the other side. I don't want to make, you know, me versus them. I said, I'm just going to go to the class and I'm just going to show them the data. That's all I'm going to do. So I remember giving the talk to the kids and just showing them all the data. At the end, a little girl, her family is probably one of the most left-leaning in the school. She ran up to me and gave me a big hug. She says, oh, Dr. Frank, that was so wonderful. She says, no, I don't believe in global warming. And I said, oh man, now am I in trouble. So the next day, her mom comes to the school, and she's like, you know, I get called to the office, and I'm sitting there, you know, in the principal's office, and she's all upset. And I said, well, look, you know, all I did was show them the data and talk them through the data so they can make up their own mind. And I said, here, and she was like, all fierce. I said, here, let me show you the data. And so as I started to show her the data, she's like, nope, I don't want to see the data. I'm not looking at the data. I already know what to think. That is the problem that we have with global warming. That is why the public is in the situation it's in right now, in my opinion. They've already been told what to think. They already know what to think. And that's my job. That's, you know, I showed it was just a bunch of graphs. I'm just showing her a bunch of data, but she has nothing to do with it. So, you know, another example of this is my son, Derek. When he was in first grade, he and I were in the backyard digging a foundation for a new shed. And I took my shovel and I turned over a gorgeous soil. And it was just full of worms and bugs and grubs. Oh, it's awesome. I said, oh, son, cool. Look, let's look at that. So we got down on our hands and knees, and I was like pulling through the clods to look at the bugs together. What a great thing for a father and a son to do. And he goes, oh, no, Dad. He says, Dad, you're destroying habitat. That was the moment that I realized that my children were being indoctrinated in school, not taught in school about these kinds of issues. And so I think our whole culture has been educated and conditioned to think a certain way rather than to look at the data and then understand what's going on. So those who have followed me on all my social media stuff have gotten a flavor for me. My flavor is I like to talk about the data. I like to show the data. I haven't done as much COVID data lately because I've been so busy with another big project. But I still like to show lots of data. I like to help show people how to follow the data. There's a common theme in a lot of what I do. Science and politics do not play well together. You'll see me say that a lot of times. One of the things that just drives me crazy is when politicians cherry pick data. So they'll have a certain agenda and they pick just what they need. That's called lying with statistics. And the public doesn't understand the data. And so they're easily manipulated. So I like to try to teach people the data when I'm online. And of course, the media and the government institutions are complicit. One of the reasons why I left academics in 1996 is I just couldn't honestly write proposals anymore. I felt like I was lying every time I was writing proposals. You have to justify why you're getting the grant funds that you're getting. And I remember going to a class on grant writing, and the teacher of the class said, just put climate change in the first paragraph and it doubles your chance of getting funded. Might not have anything to do with climate change, but if you do that, it helps you get funded. So that isn't my personality. So I end up playing a lot of what I call statistical whack-a-mole. Statistical whack-a-mole is when there are all these things coming up that people say, oh, we have food shortages, we have coral reefs, we have ocean acidification, we have severe storms, glacial melting. All these things are being thrown at you as problems with climate change. And so I'm sitting there every time one of these things come up, I pound it back down. I pound it. They raise some issue, and I say, now wait a minute, let's look at the data. So you look at the data, doesn't confirm what they said, does it? Okay. Next topic comes up, doesn't confirm. It's like you end up playing that over and over again. The problem is they can come up with lies faster than you can pound them down. So there's a lot of work. And you guys know from this last year, because you've had experience with this with another subject, COVID. Double masks, close the schools, shut downs. Flatten the curve. You've heard all that stuff, so you know that this is an old system. This is not a new system that's being used. So anyway, let's use a practical example here. So a few years ago, I was somewhere or in 2005, 2006, or in there. A lady at my church ran up to me and says, Doug, what about the polar bears? We're going to lose all of our polar bears because of climate change. And I said, what? I said I hadn't heard anything about that, but I'll research it for you. So I read the article, about how worried we have to be about the polar bears. And then it had made a reference to an earlier article. So I went and I read that article, and it made reference to an earlier article. And it's kind of like the game of telegraph. Every time they tell the story, it gets a little different. And I got back to the original study, and the original study was a guy up near Anchorage who was studying a polar bear population there. He was very interested in the polar bear population there because he was concerned about the effluents, the pollution coming out of a plant that was on one of the rivers there. The pollution was getting into the food supply, into the fish, that the bears were eating the fish. And it just so happens that the poisons, the pollution that the fish were getting in their body that was getting into the bears was concentrating in the gonads of the polar bears. So he was going around to all the local Eskimos who are allowed to hunt, or the natives, not Eskimos, the natives are allowed to hunt polar bears, and he would have them keep the gonads, he'd keep the ovaries, keep the male genitals parts, and put them in Ziploc bags, and he would study those. And he'd been doing that for years. So he hired a helicopter to fly over and do a survey of the whole population of the bears. And then 2 years later, he did another flyover, and he noticed that the population, like the first time was something like 1,100, and the second time it was something like 1,050. And it was just one little region. It's a negligible thing. It's 2 data points. That experiment right there, the one I just described to you, a guy who's been studying bear gonads for 20 years, did 2 surveys. That's what gave you this cover article on Time magazine. And when you track it back, you realize everything gets interpreted through the lens of climate change, even though it had nothing to do with it. It's a great story, and it's what really happened. So bottom line is, our polar bears, they're fine if you actually look at it and look into the numbers. And in fact, they are thriving up there at their northern home. Their population has quadrupled since the 70s. And it's become a real problem. They've got so many bears up there. So when you hear that the polar bear's at risk, no, you look at the data. The data don't say that at all. Or a guy at church to me one time, he came in and says he'd just come back from Florida, and all the newspapers were talking about how there's be this big problem with sea level rise in their community. And I said, oh, really? I said, what community do you live in? And I just happened to have my computer with me that day. I was given a PowerPoint and Bible study or something. I don't remember. We log into the NAO website, and here, let's see if I can go ahead to that. I got this out of order. We log in and we look, because you can actually look at the graph for every community. It's not hard. And it wasn't even going up in his community. And he was like, well, wait a minute, why are they all worried about it then? I said, I don't know, maybe there's a request for proposal to build a new seawall or something like that. Maybe they're trying to justify it. I don't know. But the point is, it wasn't going up. So what's surprising is, I think to most people, is that they're being bombarded with all this bad stuff. But when you actually look into it, case after case after case, there's not anything. And like what's really going on with sea level rise is, this is 8,000 years here of history. And you notice that it's gone up about, 16 meters in 8,000 years. And here we are in the last 100 years. It's gone up 20 centimeters. Here, I'll show you 20 centimeters. Here's a ruler, right? So here's a ruler. So this is 20 centimeters, okay? So it's gone up 20 centimeters in 100 years. That's how much it's going up. And you can see it looks linear there. So are you worried about sea level rise? No. Then why are we talking about it? Good question. So it's amazing when you actually look at the data, it isn't what you think it is. Now, fortunately for me, I'm not the only one out there debunking this stuff. One of my favorite professors, he's a Berkeley professor, Richard Muller's his name. He teaches a class, Physics for Future Presidents. It's basically for non-science majors to teach them how to be the scientific thinking. And he leans left, but he's a great thinker. I can't believe how much he and I think alike. When I read his books, I feel like I could have written that. It sounds like me. He says things, though, that are politically incorrect. You'll hear him on NPR a lot. But like he says, every environmentalist should favor fracking. And I'll explain why later. It's amazing. But one of my favorite things about him, he in his book, Energy for Future Presidents, he basically debunks all of the claims that you've heard, like sea level rise or more storms or more severe storms or all the things that you hear, more tornadoes, all those kinds of things that you hear that are, more forest fires, all those kinds of claims that you hear, he basically takes them one at a time and debunks them. It's pretty fun book if you want a fun book to read. He's really entertaining to read. He, in one chapter, he talks about alternative forms of energy, and he asks the question, which is the densest form of chemical energy on the planet? And not surprisingly, the answer is oil. And so it's not a surprise that we use oil to move energy around a lot when we need chemical energy, when we need it to run our cars or whatnot. But then he said, what's the second densest chemical means to spread energy around the planet? And he does the calculation for you, and it's fun. It's the chocolate chip cookie. So that's fun.
Frank, hey, I've got a question for you.
Yeah.
So one of our listeners, Dave, asked a question. So if somebody talks to me about polar bears, what is the source or reference? What kind of, are there any stats I can give on that, or any kind of information I can look at?
Yeah, just if you were to Google or DuckDuckGo and say polar bear population, I mean, half a dozen sites come up. I didn't make that up. It's pretty easy to find. I didn't put the reference on there. I meant to put it on there. Sorry about that. But it's pretty easy to find. I just Googled it to get it. So.
Yeah. So another thing, we were traveling in South Carolina a few weeks back, and
yeah,
there were all these articles in the paper that were scaring everybody about the flood insurance plane, and the flood insurance plane had risen all this amount, and people would be charged so much money. How do you counter something that when there's that information?
Well, if it's a floodplain, it's going to flood every once in a while. Don't build in the floodplain. So, right. I mean, and I'm going to show some graphs later. There are a lot of natural cycles in nature, and they're serious. They're big. They affect what happens. And so I wouldn't want to build in a floodplain. I guess that would be my answer.
Got it.
I mean, or if it's going to happen, it's sort of like in recent years, people have built a lot near seashores. And, if you were to build on the east coast of Florida, the southern tip, you pretty much know you're going to get a hurricane now and then, right? So you better plan for it. And, that's not due to any climate change. Dude, we've had hurricanes for thousands and thousands of years. You can pretty much count on it. So maybe that would be kind of my casual answer to your question.
Thank you.
Yeah, no worries. But another thing that has come up is ClimateGate, and it just won't go away. There's still lawsuits going on about it. And Richard Muller, he has a really good video on it. So if you're interested in learning about ClimateGate, he just rips into these guys, and I just love it. So he's kind of like a hero. I enjoy him, even though he's a believer in anthropogenic climate change. So, but he's fun because he debunks a lot of it. So here I am, Doug Frank, trying to convince you that climate change, maybe you don't have to worry about so much. And here's a guy, Richard Muller, who says he thinks it is an issue. So I'm giving you kind of a way to double check me and verify. But he's debunked just about every claim there is except one. And I'm about to show you that one. So also, people in the media don't understand science. Back in the 90s, I was kind of famous. I mentioned that from a discovery. And I had cover articles and leading journals. And so, the Cincinnati Enquirer would come by to interview me, and magazines would come interview me. And I'm telling you, they never got the science right, ever. They would send me galley proofs to check. It didn't matter. The media never gets it right. So a hint to you guys out there, don't get your climate change data from the media. When you want to know what's going on with the climate, go look at the data. Go to a source for data, not the New York Times, not CNN, not Fox. Don't go to the regular media to get your information, because they never get it right. And so anyway, how did I get into all this? So in 1981, at my chemistry department at Westmont, you mentioned I was there, or 80, I guess it was. We had a guy come and speak to our department. He's the guy who coined the phrase greenhouse effect. And he was trying to get everybody. He was going around university to university trying to convince everybody to burn all the coal they could burn to try to use the greenhouse effect as a way of mitigating the impending ice age. Okay, he was trying to get everybody to use global warming to try to warm the planet. I think he was a big leader at Greenpeace too. So it's very interesting. And a lot of you will remember this if you're old enough. That was back in those days. And the verbiage is all the same. It's just the opposite. There were ominous signs that the Earth's weather patterns begin to change dramatically, right? And they got all the graphs. Now this is back then, so they didn't have the pretty graphics like they have today. But they're showing you a graph, and the temperature had peaked, and now the temperature was plummeting. Here we're coming up to 1970, temperature's plummeting, and of course that was it. Here comes the ice age. Get ready. Geologists have been telling us that we're due for an ice age. We've been due for hundreds of years. It's time for an ice age, but geological times are slow moving, not fast time. So that peak is real, and that peak is actually in the data. But if you look at the longer scale, before I get there, ever since that symposium, I've been following carefully because I was very interested. Here I am, a young student. Oh my gosh, the world's coming to an end. We're gonna have an ice age. Very interesting. So I would tear out every magazine article, and I have files and files full of articles that I read on it to keeping track. So I know the data. So it's annoying to me when I hear the media and politicians misrepresenting the data, since I know what the data are. All right, so back to this lovely graph. That bump is real, but it's part of a bigger trend, and that's what I'm trying to show you here. It's part of a larger trend, and the greenhouse effect is real, but it's not as big of an effect as people think it is. You experience it every day with your car. For example, if you have your car parked outside, the sunlight comes in. When it interacts with the inside of your car, it loses a little bit of its energy, so that it isn't white light anymore. And the red light, the infrared light, is stuck inside your car, and so it warms up the inside of your car. It's called the greenhouse effect. Well, the same thing can happen in our atmosphere. The light from the sun comes in, interacts with the ground or the atmosphere, and the infrared gets trapped. That's called the greenhouse effect. Now, there's a guy named Enrico Fermi, famous physicist from the Manhattan Project. And he is famous for being able to calculate just about anything that had never happened before. So you have to make lots of assumptions and combine assumptions to come up with ideas. So he was really good at it. It's really an important scientific skill. So in this class, after the speaker had come to us and said he wanted us to burn all this coal to try to warm up the planet, my organic chemistry professor, I remember, Dr. Benton, he said, okay, your guys' homework assignment tonight is to go back to your dorm room, calculate how much coal we'd have to burn to produce enough CO2 to capture enough of the sun's energy to raise the temperature of the Earth 1 degree centigrade. So if you wanted to warm the planet with the greenhouse effect, how much coal would you have to burn? So we all went back to our rooms and we did our work. Well, the answer is you'd have to burn half of the world's known coal, half at that time. And that would only last 1 year. And then you have to burn the second half of the coal for the following year to keep it 1 degree raised. And then gradually nature would just suck up that CO2 and you'd be back right where you started. So in other words, that isn't going to work. So it was sort of a way of us debunking the idea oh, gee, let's burn all this coal to try to make the greenhouse effect. But if you think about it, it's also a really interesting way to think about this effect. CO2 is a very weak way to try to warm the planet. And climate change people have known this for decades. So you need to listen carefully to scientists who are trying to say that CO2 is causing climate change, because they never say that. They say that CO2 causes something like at a tipping point that causes something else to happen, because CO2 is really a weak absorber, weak interactor, and there's just almost none of it in the air. It's tiny. I mean, you have to measure it in hundreds of parts per million. It's not a lot of it. So you'll always hear them talk about tipping points when they're talking about it. And of course, we wouldn't have any more coal if we tried that approach, and we'd be all out of coal. So can you imagine if we'd been spending the last 30 years trying to warm the planet? We'd probably be taking credit for the observed very small temperature change that we've seen. It just shows the ludicrousness of these kinds of talks. Really, the question is in all of our years as human, how much difference have we made, right? The question isn't whether there's climate change or not. Everyone admits that climate changes. The question is how much are we causing? And there have been really good studies of that, and you have to read the literature, but you can find them. Because the problem is there's a lot of natural variability. There's a lot of feedback loops that are always going on. For example, pretend that CO2 actually did cause warming. Okay, so we put some CO2 up there. Let's say that the atmosphere warms up a little bit. Well, when it warms up a little bit, then it causes more water to evaporate from the ocean because it's warmer, right? So then when that water goes up into the atmosphere, it forms more clouds. But when you form more clouds, you reflect more sunlight back into space, so the planet cools down. So there's no effect that's by itself. Every effect is in some kind of feedback loop. You do a little bit of this, that compensates. Do a little bit, and then when that compensates, something else is compensating for that, and that compensating for that. It's an integrated web of amazing amount of feedback loops going on in our climate, and it's a good thing. That's good for us as humans, because if it didn't do that, we'd have massive temperature swings, and it would not be a very good thing. There's also some other long-term cycles. For example, they're called Milankovic cycles. And basically what it boils down to is the planet Earth is not in a spherical, it's not in a circular orbit. It's a little bit elliptical. So sometimes our planet's closer to the sun. Sometimes it's further from the sun. When it's closer to the sun, it gets a little more heat than usual. When it's further away from the sun, it gets a little less heat than usual. And when you track those cycles, they correspond to our ice ages. So they're those long, big, long-term. Those are 10,000 years or so. Every 10,000 years, we'll have a little ice age. We'll have an ice age. But then there's also major ice age about every 100,000. I mean, there's big cycles, and those are called Milankovic cycles. But also,
Hey,
you could look.
Dr. Frank,
Yeah.
one of our persons online tonight Quentin wanted to kind of ask you, what do you refer to this climate? You refer to it as, like Rush Limbaugh, he said, would refer to it as climate patterns. Is that how you refer to it, or do you refer to it as cycles, or what's the right terminology?
I like cycles because so much is cyclical. A pattern, you could call a cycle a pattern. So maybe pattern is more general.
Got it.
Yeah, but I think in cycles. Because to me, I mean, I teach my students that everything in the universe is vibrating. So a vibration is a cycle. So you could call it a pattern, I guess.
Okay.
But if you cut any tree down, look at the rings, and you'll notice that every ring isn't the same in a tree ring. There's the El Nino cycle out in the ocean. It's like every 5 or 6 years produces what they call the Pacific decadal oscillation. It changes the weather in the United States, but it's a longer term cycle. And then the Milankovic cycles, that's solar system stuff, but they're longer term. So there's all this natural variability. So the question is if it starts going up, is that because of us, or is it because of one of these cycles? Well, in order to know, you have to have long enough term data to be able to evaluate it. So we need lots of data for that. Now, somebody did a really cool calculation back here in 2007, and I just loved this calculation. And there's a term, it's called climate sensitivity. And it's a scientific term. And what it means is if you double the amount of CO2 in the atmosphere, how much will the temperature change? That's what it's called. And scientists have been arguing about that for 40 years, and they still haven't settled on a number, because there are too many of these other things that are going on, climate sensitivity. And so the question this article is asking is, why is it so unpredictable? And the answer is because there's so much natural variability that even if you allow us to affect it a little bit, let's pretend that we're affecting it a little bit, the variability is 3 times or 4 times bigger than the amount we could affect it. So the problem is you got all these oscillations going on, natural things happening, and it's hard to pick out what our contribution might be. So I like to explain that to people in terms of flipping a coin. Let's say I flip a coin 10 times and you get 6 heads and 4 tails. You wouldn't think anything about that. And so you'd think, okay, that's pretty normal. So let's say I flip it 10 more times and now I've got a total of 20 flips. Now I'm up to, 8 and 12. Well, maybe you're starting to suspect, maybe, that something wrong with that coin. You keep flipping, keep flipping. Eventually, maybe when you're up to 100 flips, it better be close to like 48, 52, something like that. The numbers need to be converging to the middle, huh? So you need lots of flips in order to find out whether the coin is really true or not. Well, it's the same way with the climate. You need lots of years to know if we're causing the effect or whether it was already there in nature. And this article calculates it for you. Guess what? This is the result of the article. It's going to take us 200 years to know with 50% probability, a coin flip, if we have an effect or not. In other words, in order to pick out our effect, if we did have an effect, we need 200 more years of data. And then, even then, we're only 50% sure. That is a really good way to look at climate change. Because you notice burning all that coal only makes a small difference. There's all this natural variability. So it's hidden, isn't it? Our effect is hidden in the middle of a lot of other things. So this is what my son was talking about. He's saying, show him the data. Well, here's 65 million years of data. Okay, so this is a big time scale. And this is the present over here on the left. And here's 65 million years ago. Okay, long time. And then, you've got your the dinosaurs are in here, right? So you notice that since then, the Earth has been cooling down. Look at it cooling down. In fact, it's cooled down about 20 degrees centigrade. We're actually relatively cold right now. We're relatively cold. And here's our last ice age. So that's, as a planet, we used to be warmer. Here we go. We got 4,000 million years here. And you can notice that over time, there's oscillations in CO2 and there's oscillations in temperature. And you don't have to look too closely at this if you don't want. Here's the Cretaceous. Here's where the dinosaurs are here. And, this is 60 million years ago. And you can see since then that this blue curve here, you can see that the temperatures come down and so is the CO2. And the question is the CO2 causing the temperature to come down or is the temperature causing the CO2 to go down? And there's ways we can answer that. This article was published in Scientific American in 2008. It's a great article. They show you some data for various ice cores. And I'll show you a picture of an ice core in a little bit. And if you zoom in and look at it carefully, what you realize is that the temperature goes up before the CO2 goes up, before the sea level goes up. So imagine you've got a Coca-Cola in your hand and it's cold and you open it. Okay. Now imagine you've got a Coca-Cola in your hand and it's hot. Open it. Now you got a mess, huh? In other words, if you warm the water up, the CO2 comes out more. That's what carbonation is. It's CO2 and you're mixed in the liquid. It's the same with the ocean. If the ocean's warmer, more CO2 comes out of the ocean. So it's interesting because people think that when you look at these data in the past, that the reason why the CO2 is going up is because the temperature is going up. The temperature is the CO2 is 800 years behind the temperature. So the temperature goes up first, then the CO2 comes up. Why 800 years? Because that's how long it takes for the ocean to completely cycle. There's lots of undercurrents in the ocean, and it takes a long time for all those currents to circulate all the way to the surface where the CO2 can come out. So,
hey, Dr. Frank, so
yes.
our friend Christopher wants to know, where can you go to find this kind of long-term data that kind of puts this panic-inducing short-term fluctuation?
Well, this one's from Scientific American, 2007.
Now, would it be best just to DuckDuckGo or Google that, or
Yeah, I like looking up the Vostok Glacier, VOSTOK, the Vostok Glacier ice cores. Those are really handy. There's lots of sedimentary data out there. And, this isn't, you notice that this isn't my graph. This is right out of Scientific American, which, by the way, is pro-anthropogenic climate change. So here I am using their own data to show you that the temperature leads the CO2, which leads the sea level as well.
And of course, the people that are most concerned about this are saying it's exactly the opposite way around, right?
Right. And the data don't support that.
So how many years ago I just want to put this in perspective and make sure I understand it. How many years ago did climate change really start to be such a big thing? Was it when Al came out with his movie, or was it 20 years ago? Is that about when it started, the really big push?
The real big stuff, yeah. Like, for example, I pointed out there in 80, they were worried about the coming ice age, right? 1980. And then the mid 90s, it started changing over to global warming.
So that's 30 years. And essentially what you're telling everybody tonight, and I want to make sure I understand this, you're telling everybody, really, for us to really know if this is real, we have to study it for 200 years. We've got 30 years.
Right.
200 years. It's a roll of the dice crapshoot.
Yes.
50, whether we've even got it right.
Yes.
So do I need to take my 3-card Monty board out and play a little 3-card Monty with people to help them understand this? Or what is the fascination? What is this inertia behind this?
Well, I mentioned one of them, and that is that, every person writing a grant proposal at a university wants funding. And how do they get funding? They explore the cause, the cause du jour, the whatever's going on at the time. That's the scary thing. And politicians like to scare us. Does this sound familiar? Because when they scare us, they can control us. So that's what's going on here. There really isn't, you mentioned Rush Limbaugh a little bit ago. The guy isn't a scientist, but he had this right. He had this right from the beginning, that it wasn't about the science, it was about the politics. And so everything you're hearing about climate change in the media and politics isn't really about climate change. It's really about the politics.
And our friend Dave, I think he asked a really good question. When you're Googling stuff, how can you tell? There's so many different spins people have on it. And I know this is Christopher's question. How can you tell which sites that you kind of need to be skeptical about? Is there any kind of way to put that filter on there?
I try to get back as close to the raw data as I possibly can. It's like I showed you in that article with the polar bears, right? Don't read Time magazine. That's the worst. And then, the one before that and the one before that. Try to get back to the original scientific paper, as close to the original data as you can, and then you'll know what's going on. And I appreciate it. For example, in Science magazine, they'll have an editorial section in the beginning where they say, this is what you should think about these data. But I almost never read that. I almost always went back to the journal papers, because real scientists, tend to be far more reserved in the claims they make from the data. Whereas when people like, a couple of polar bears missing their gonads, and suddenly, we've got climate, we're losing all of our polar bears. So it gets reinterpreted. So I get back to the data as close as you can to the data. And sometimes you have to dig a little bit, but I've been digging for a lot of years, so I have some pretty good sources. I'm going to show you guys one here in a minute.
And Stephen has a lot of good comments, and he said, based upon the data I've seen over the last year, it shows from the UN models that they are overestimating the observed temperature rise by 2 to 3 times. Is that that's your experience?
Absolutely, and that would be a low estimate. They're doing. I've got a graph showing that it's preposterous. And I'm going to explain why that happens too. I'll show you guys. I'll give a longer answer to that.
Okay, so before I let you move on, and so interesting. I've just got a question that I think kind of sums up some of the questions that people have been asking.
Sure.
So from our perspective, not you, because you know what to say. What do we say to people that say to us, that there is a consensus that that global warming is real? What does somebody out in the audience say back?
If anybody says to me, the scientific consensus is, as soon as they say that, I say to myself, this person doesn't understand science. because I've never been in a scientific meeting ever in my life where there was a consensus. Scientists disagree about everything. Okay, we argue every detail and we dig into each other. Scientists don't have consensus. The word consensus is a political term, not a scientific one. So that's the first thing that happens. They'll say, oh, well, the consensus is. So that's one of the problems people have. If I like the questions that you're asking. If somebody's trying to find data on it, don't go to the NASA website. The NASA website's like full of consensus opinions, not even data. So go where the data are, not where somebody who's interpreted the data's opinion is. Find the data, dig for the data.
Got it.
And that's what I do. That's how I cut through the politics.
An anonymous attendee kind of had a funny comment. He said, when they ask me that question, I always ask the person, how did Greenland get its name? It is green again now. And, tell me when it is. So
yeah, right. Exactly.
That might be something to think about. I'll let you keep.
All right. No, those are great questions. I appreciate it. Hopefully I'll answer some of them.
Yeah.
I put this together a few years ago to help. One of the things I'm struggling with is you guys are asking how do you convey these ideas to people? So that's what I'm trying to help you guys with tonight. How do you do this? So I show this phone. This is the size of my phone. It has 1440 by 2560 pixels. Screen resolution. That's my screen resolution. That's 3,686,400 pixels. I made it sky blue to represent 3,686,400 molecules in the atmosphere. 2,875,000. I'm not going to keep reading these numbers. A big amount of its nitrogen, big amount of its oxygen, big amount of its argon, and this teeny little bit, 1,475 of the pixels in here are CO2. 369 out of that 1475 are there because of stuff we've done. In other words, there's already a lot more CO2 that we didn't put there. In other words, it's a very tiny amount. Well, what I did was I changed 369 of the pixels in this image from sky blue to black. Oh, you didn't notice? Neither does the climate. So this is the sort of way I like to help people understand. Here's another way to help people understand about CO2. If you take a CO2 detector and you walk out into the middle of a cornfield and you measure the CO2, it's 0. Why is it 0? Answer, the corn plants are sucking it up like crazy. That's their food. Plants eat CO2 and they are trying to grow as fast as they possibly can. If you give them more CO2, if the atmospheric CO2 went up more, this would still be 0. Because why? The plants would grow faster. You're feeding them faster. Okay, so in other words, CO2 is a good thing. We're feeding our plants. Here's another question I like to ask people who are trying to think about this. So what would be the right temperature for the world to be? Okay, you're all afraid that the temperature is going to go up. Oh, we're all going to die, global warming. Okay, well, what would be the right temperature? Should we be 2 degrees colder? Should we be 2 degrees warmer? What should we be? What's the right temperature? Well, there have been studies of this, and the answer is we should be 2 degrees warmer. And there are all kinds of reasons why that is. But one of them is you have longer growing seasons. You have less energy consumption because people don't have to heat their houses as long. Also, there's an interesting curve. People live a little bit longer if it's a little bit warmer on average. So, for human thriving, there's some scientist in Denmark who did a really cool study, and he thinks we ought to be 2 degrees warmer. Now, it's interesting because a few years back, a group of 60 scientists in Canada wrote a letter to their government saying, don't do anything to stop global warming. We want it warmer. We want to have more growing season. We want to have less energy costs. So, in other words, it's interesting, isn't it? Isn't it interesting how they say, global warming, oh, danger, danger, we're going to get warmer. But wait a minute, nobody's saying, what should the temperature be? Let's have it a little warmer. It might be better. Okay. What else might a warmer temperature help? Well, NASA just published this a few years ago. They said that the planet is greening up dramatically. The plants are growing more of the land is covered with plants than before. I wonder why. We have a little more CO2 in the air. Hey, a little more CO2, that's plant food. So of course we have more plants, more happy plants. But now think about that. If you have more happy plants, that means you also have more happy humans because we have more happy food and more happy oxygen. And also, by the way, more plants causes more respiration, which cools the planet, which is where I'm going with you guys. There are all these cycles built into nature that balance things out. It's remarkable. So anyway, that's one example. That good. And people, one of the big claims is they say, oh, if we have global warming, we're going to have decreased food production. Oh yeah, well here's this food production, you know, since the last 60 years, okay? And you can see, no, food production just keeps shooting up. We're not having any trouble with food production. And if you think about it, of course we do. We have more CO2 in the air. Our plants love it. So if you ever go to a greenhouse, they even have CO2 manufacturing machines inside the greenhouse, because if they pump in more CO2, the plants grow faster. They do it on purpose. And you know, here's an example. If you grow soybeans at 400 ppm, you get this result. If you grow at 800 ppm, you get twice as much mass. More CO2 is a good thing.
Dr. Frank, one of our guests made the comment, and I think it's a good one. Science and politics do not mix well. President Eisenhower, in his farewell address, warned that government-sponsored research will contaminate science. When you're looking at the data, if it's coming from the government, are you kind of just pushing that to the back? I mean, is it that bad that you can't really trust much that comes out, kind of like a CDC or United Nations?
Yeah, you have to be skeptical at first. And I'm about to show you some data for the United States for the temperature data, and I'm going to show you what's wrong with it and what scientists did about it.
Thanks. Let me just get one more question.
Yeah, sure.
So Corey has a great comment here. Thank you, Dr. Frank, for your work. I'm just so happy to be here tonight with my 10-year-old daughter that is constantly listening to her friends try to save the polar bears. Great to have a resource like you. So glad your talk tonight is in crayons. Yeah, I think that's helpful. And her question
I've only shown you a couple of graphs so far, right?
Her question is about weather modification. Do you theorize that it might affect climate change? If it does at all, and if so, how?
Oh yeah. In fact, it's interesting because when global warming became a big issue, it was around 2002 or 2003, the Union of Geophysical Engineers had a special annual meeting because, of course, we were all worried about climate change. And it was a international meeting. All these geologists came from around the world, geophysicists, and they had a conference. And the whole purpose of the conference was, what can we do to mitigate global warming? What engineering techniques do we have? And it was a dud of a meeting, because when they thought about it, they had a whole list. They had like 10 no-brainers. They didn't have to work at it, of ways to cool the planet. So if we did have a problem with the planet heating, we got plenty of ways to cool it down if we wanted. And what was amazing is when they published those results, I remember reading those results in Science magazine. It was a big splash. They were assaulted by the world community. How dare you suggest ways that we could mitigate global warming? No, we have to attack CO2. You could tell it was a political thing. It wasn't really global warming they were worried about. They want to control CO2.
Okay, so Dr. Frank, I've got to be honest with you. I don't understand recycling very well, and my wife is continuously telling me, no, that little container there, you can't put that in recycling, and no, you're stupid, you don't do it the right way. And so you know, and I feel so inferior. And Michelle here asked the question, and she says, I'm wondering how recycling plays into climate change.
I checked into that about 15 years ago, and I read a really interesting study by the EPA. And what they did is they did a birth to death calculation. And what this is this. So let's say you want to make a glass bottle. Well, you got to get the sand. You got to scoop up the sand. You got to clean the sand. You got to truck it to the plant where you're going to make the glass bottles. You got to melt the sand. You got to form it into the bottle. You got to, clean it all up and ship it to the manufacturer who's going to put Coca-Cola in it or whatever it is, right? And then they ship it to you, and it's been shipped, right? So there's a lot of energy that went into that, huh? Okay. Yeah. So now you've got that bottle in your hand. You finish your Coke. What do you do with that bottle? Well, if you want to reuse it, well, you're going to put it in the recycling bin, right? And then the truck has to come by and pick it up. They have to take it to the dump, and they have to sort it out. And it takes energy and time and money and resources. They sort it out from the other garbage. Then they have to put all the glass together. Then they have to take that to a plant where they're going to clean up all the bottles and smush them and remelt them and make them into new glass bottles and all that. And so they did that. They did that calculation for a whole bunch of things we typically recycle. everything they checked took more energy to recycle, except 3 things. In other words, it was a bad idea to recycle. You weren't helping the environment. 3 things. One was those plastic milk cartons.
Right.
Those are really good. Another one's aluminum cans. And aluminum cans make a lot of sense because if you understand electrochemistry, that's my PhD, electrochemistry, every aluminum atom takes 3 electrons to reduce to an aluminum metal. It's expensive. And you know, a lot of our aluminum comes from Australia. There's some regions in Australia where they'll just have a massive power plant that does nothing except make a bauxite ore into aluminum metal. I mean, it takes a ton of power. So recycling aluminum can makes a lot of sense. So and carpet. Carpet was the other one. Recycling carpet's a good one. And all the rest of them, the EPA said, took more energy to recycle. It was a net negative. It was better just to put it in a landfill. Better for the environment.
I don't want anybody out looking around my trash, Dr. Frank. But I've heard so much about it. I don't know what to think about it. So Joe, kind of someone I believe I know, he was talking about Brian Sussman's book Climate Gate, and it backs up some of your CO2 information. That he says in the atmosphere, it's only. And by the way, Joe donated that book to the Empower You Library if anybody ever wants to borrow it once we get open on April 6th. But he says the amount of CO2 in the atmosphere is only 0.038%. And he says, to me, this is an incredibly small amount, yet it's claimed that CO2 is one of the main components of climate change.
Right. But I pointed out already, even the climate scientists know it has a tiny effect, which is why they're always talking about tipping points. It isn't enough itself to do the job. Remember, that's why I gave you the example. You'd have to burn half of the coal in the world just to raise the temperature of the Earth 1 degree. And it would only last a year.
And you know, some people on some sides of the political aisle would like to burn all the coal in 1 year, Dr. Frank. But you know, Sandy has an interesting question, and I think Sandy's feeling a little bit intellectually challenged. Well, I don't want to speak for her like me, but because so where are they coming up with the 9 to 12 year claim that we have left to save the planet? And Sandy and I just aren't quite smart enough to get that. Can you help us with that? Or
well, I showed you the cover of Time magazine, right?
Yes.
I didn't read you the sub headlines. One of them was "It's already too late," and every couple of years they recycle that. This is our last chance, you know.
Good. I'll let you keep going. Sorry.
The IPCC report in 2000 said we weren't going to have any glaciers left by 2012. So I think we're doing pretty good out there. What do you think?
Great.
It's why you don't get your science that way. The science that you get through the media or through the politics is not real science. It's designed to manipulate you, and it's not the real thing. So anyway, you got to dig a little deeper. Oh, there's some benefits of global warming there. Okay, the bottom line is CO2 is not bad. It's not bad at all. In fact, you got to have it or you'll be dead. We need CO2. All your cells are made of CO2, right? All the food you eat is made of CO2. You need CO2. So people who talk about it being a bad thing, don't think of CO2 as bad. It's part of a whole cycle. We need the carbon cycle is life. It's everything, man. You got to have it. Now, this is a fun one. So in 1991 or 2, I can't remember. That's one of the two. They had the Kyoto Accords where all the nations came together and said, "Oh my gosh, we gotta regulate all the nations' CO2." So NASA got the bright idea that they were going to fly jets in the high atmosphere above the continents and measure how much CO2. Hey, if we're going to regulate countries, we better know how much is up there. And they're going to set up a monitoring pattern. So they started monitoring it. What they found was that in America, we consume more CO2 than we produce. And everybody was shocked. They were like, how can that possibly be? We've got all these, we use 1/4 of the world's power. How can it be that we are consuming more CO2 than we make? And the answer is trees. When the Native Americans were dominating our continent, they would cut down vast areas of the plains to make grazing lands for the grazing animals, for their herds. They were basically feeding their herds. And what would happen is now all those trees are growing back, and trees are huge carbon sinks. So the CO2 comes into America and our trees just suck it up. So they just gulp that stuff up. And you know that's true. When you walk through a forest, you feel that all that fresh oxygen in this, and the trees are just sucking up all the CO2. It's beautiful in there. Now, this is global CO2 emissions by world region. This is us here at the United States. And one of the things people don't understand is since we started fracking, we've been going down in CO2 emissions for about 10 years straight now. We're producing less and less CO2 in the world. That's why Mueller likes fracking, because he thinks that anthropogenic climate change is real. So by fracking, instead of burning coal, which produces more CO2, we're burning natural gas, which produces more energy in relationship to the amount of CO2 it makes. So we're going down. But look at the real problem here. China's exploding. So even if we completely eliminated the amount of CO2 we made in the United States, China in 3 years would replace annually the amount we've been producing annually, because they're growing at a massive rate. I think a couple of years ago, I was reading an article. They were building in a single year 400 new coal-powered power plants. It's just remarkable. So, anything you think you're making a difference in America. Oh, gee, today, I turned the lights off and saved a little energy. Hooray, hooray, I'm saving the planet. China, in the last second, used up your allotment for the whole year. So the problem in climate change, even if it were real, is not us. America's not the problem. We're not the issue. It's the developing nations. And by the way, like I pointed out, that's why Dr. Mueller thinks that fracking is great. So bottom line, humans have very little to do with the Earth's climate. And why do I think that way? It's simple, because I follow the data and the science. And I'm going to show you some data here. And I mentioned it, we mentioned scientific consensus. That's a political claim, and they're confused about the science. I just want to show you, at least before it gets too much, before we lose, this is the graph a lot of us were looking at when we were first started talking about climate change. It shows from about 1850 to about 2005 or so. And what I want you to notice about that is this is when they were all worried about the Earth having an ice age. And then, of course, the direction, this is where everybody's worried about everything burning up. But I want you to notice that from about 1910 to about 1940, that the temperatures were rising. And guess what? Since about 1965 till now, the temperature's rising. But I want you to notice those two rates. They're exactly the same. In other words, before we were putting much CO2 into the air, the nature was already increasing at rates like this. It's some natural cycle. So this is why variability matters. This wasn't us causing it. Why is this one suddenly us causing it? So that's why you need to know what the data are. It's not global cooling. It's not global warming. It's weather. Now, this is what you guys need to understand about the way we talk about, the way you usually hear people talk about global warming. These little red dots showing you all the places in the world where there's a weather station. You might have seen them before. There's like little white huts, and they've got temperatures in there. And this is where all the weather stations are in the world. And when you look at that, you go, well, wow, there sure are a lot of weather stations in America, and there sure are a lot of in Europe, and maybe over here in the East. But the rest of them, they're not like even evenly spread out. They're all over the place. So to get an average global temperature this way, that's the kind of situation where they got these data here. And it's not a very good way to measure it, is it? And there's another big problem too with measuring temperatures at the surface. Here's a temperature station at the University of Arizona, and it's one of the ones where its temperature is added to the average national temperature. And it's in the middle of a parking lot on asphalt. And anybody who's ever walked across asphalt on a summer day knows that's way hotter than when you're over in the trees in the cool shade or in a forest or whatnot. And too many of our national stations are positioned like this incorrectly. In fact, a guy named Anthony Watts, he has a website called What's Up With That. It's the world's most viewed site on global warming. So somebody a minute ago was asking, where do you get good data? I like this website. I don't agree with everything that's on it, but it's a good source of data. And I go there a lot. Anyway,
Dr.
Yeah.
Frank, John wants to know about the Vostok temperature data,
Yeah.
which appears to predict that we're heading for cooling. How do naysayers contradict that?
Oh yeah. Well, we're on the Vostok data. I showed that it's about every 100,000 years or so, and we're at one of those peaks. So we're supposed to be going into a global cooling age. But the problem is that might be 1,000 years, till that happens. The geological time scales are much longer than years in my life.
Peg makes the comment, science is never settled.
Right, never.
Which is a good comment. And Quentin wants to know about the data compiled by Bjorn Lomborg. Do you like his stuff? Yeah, I saw a couple what looked like great books from him. I can't remember the most recent one, but it looked really interesting.
Yeah, I don't usually go by author. There are a few that I like I mentioned Richard Muller. I usually just go by the data. Whoever's got some good data, that's what I go with.
And I'm getting overwhelming number of people asking me if you could cherry pick maybe some of your charts, maybe your favorite ones that they would be able to kind of put in their hand to kind of.
Well, I'll tell you what I'll do then. After this talk, I won't. I've had a long day, so I don't think I'll do it tonight. But in the next day or two, if they go to the Follow the Data with Dr. Frank page, I will put a lot of these up on that page.
Great.
And then people, and I'll put them up on the MeWe page too.
That's fantastic. Thank you.
That'll be something like 25,000 people right there that could see it.
Yeah, Beth wants to know, how do they know what old temperatures were before there were thermometers?
Man, you guys are awesome. That's coming up.
Okay.
They're called proxies, exactly. And I was just showing you that there are temperature stations that are a problem. And if you take all those out, you don't get, I'm showing you a couple other bad temperature stations. Here's a temperature station that's been in the same place for 100 years. It's correctly positioned out in the field. And you notice that for the last 100 years, the temperature has been dropping and stable, right?
Right.
Here's one. Oops, this is messed up. Sorry, I messed the slide up. But it shows the graph going up and it's next to a building. So in other words, this is called the urban heat effect. And the urban heat effect means when you're in a city or near asphalt, you get higher temperatures. What's been happening is a lot of our temperature stations are out in the country to begin with, but then our city moves out next to them. And so they get a warming trend in them, even when there's no global warming. So that's a big problem with that. Scientists recognize that. So in 1979, we launched a new set of satellites that are circulating the whole globe. So we aren't just picking all these little dots. Remember all my little red dots? We're measuring the entire globe. And you can get this data. I go here every month. Dr. Roy Spencer, he puts this up every single month. He's the one who analyzes the data for NASA. These are the actual data. And these are the data, the entire satellite data set since 1979.
Everybody write it down, please. drroyspencer.com. And
yes.
I've got somebody who wants to ask a question that's kind of on my mind.
Yeah.
What about all these people who you hear it all the time about the increase in severe weather, and this is proof that there's climate change?
That's bunk. And that was why I gave you Muller's book at the beginning. He debunks that. And I've got a slide here in a minute to show you. I can actually show you a graph, which I've been trying to avoid showing you too many graphs, showing you the number of hurricanes and whatnot. They aren't. The thing is people make these claims, and then I have to play statistical whack-a-mole and knock them down again. And but all you have to do is get the data.
And Stephen, I think, had a really interesting point that goes back to one of Dave's questions about a Canadian professor was relieved of her duties after she published a study that showed the polar bear population is increasing.
Yes, in fact, that's where those numbers came from.
Right.
That I showed earlier.
Couple other things I just have to ask, and then I'm going to ask you if you can sum it up because we're
okay, because we're going to run out of time. Okay, good.
But somebody wanted to know, and it was at the very beginning. I thought it was a good question. Let me see if I can find it. Where they wanted to know about the wind turbines and if there was any impact on. Let me see if I can find it. On avian deaths, I think was the question. I can't locate it right now. What's your sense on the wind turbines?
That's alternative energy. And if I open this door behind me, there's a white door. There's a wind turbine in there I've been working on for a couple of years. I'm very familiar with that technology, and I've done all the calculations. And when you drive through a place like Indiana and you see those big turbines everywhere, That will never pay out. I've already done the calculations. So, in other words, the only reason they're there is because of government subsidies.
And
So,
in a relation between wind turbines and avian deaths.
yes, there's a buddy of mine works at the Capitol, and he says every time he goes to these sites to inspect where the wind turbines are, he says the ground is littered with hawks and owls and big birds. So I'm not a fan of large turbines. I think they're a huge waste of money.
And this is off topic, but mathematics is one of your many talents. Any thoughts about the Gates Foundation statement that mathematics is racist?
Boy, that's off topic.
Yeah.
But Gates has been talking a lot about climate lately too.
Mm-hmm.
And mathematics, 2 + 2 is 4. It has nothing to do with what color you are.
Yeah, we talked a little bit about that on the Brian Thomas show, I think, too, the other day, didn't we? Didn't you? Yeah. So Lisa wanted to know, so are you saying then that you should just throw away all the other trash other than those 3 things?
You're actually, if you want to help the environment, that's better. Keep the cans, the aluminum cans, that's worth recycling. That's a really good thing to do. No iron cans, like soup cans and whatnot. No, that takes way too much energy. And if you got some leftover carpet, definitely recycle that. And your milk cartons. You're actually helping the environment if you do that.
Okay, you can bet what I'm going to tell my wife tonight when I get home.
I got you in trouble, did I?
You, Dr. Frank. So Stephen also said that he had heard something about 1,000 weather stations in Siberia that were shut down, which took many of the cold weather measurements out of the mix. Any truth to that?
Yes, there's a lot of truth. And Anthony Watts talks about that on his, because he did a complete study of all the weather stations. And you notice all those issues go away if you switch to the satellite data. See why I like the satellite data?
Yeah, I do. Final kind of question, and then I'm going to let you sum up.
Sure.
Is the government controlling weather?
No, I don't think so.
Thank you.
I used to listen to Art Bell when I was going to, working late. And he used to talk about stuff like that.
Yeah.
And it's not impossible. You can affect weather if you try, but it's pretty overt what you have to do. And the weather system is pretty robust. It has lots of compensating mechanisms in there. So anything you do probably gets undone pretty quickly. I mean, think about it. If you can control the weather, you wouldn't have any droughts, right? You'd make sure it rained.
Yeah. Mm-hmm.
So this is an idea I think is worth kind of summing up. But Dr. Frank, shouldn't we take action now just in case anthropogenic climate change is real? I hear this all the time. So after I've shown everybody the data and they're like, okay, I agree. This is a government thing, but there's some people believe in it. And maybe what if it's true? Shouldn't we do something about it? Absolutely not. That's called the precautionary principle. You can use the precautionary principle to justify any behavior. What if Martians invaded us tomorrow? So climate change is way down my list. There are plenty of things that we know do happen. Now, this is fun, Dan, because I was giving talks like this 20 years ago, okay? At the university and various groups, I spoke on climate change. In fact, when I was putting this talk together, I brought some of my old slides. And guess what things were on my list? Asteroid impacts. Just look at the backside of the moon sometime, okay? Look at that. The space is a dangerous place, and those asteroids are coming all the time. Coronal mass ejection. The sun is always sending out these big burps of stuff. And we've had some serious coronal mass ejections in the last couple 100 years in the United States. If we get hit by one of these, which are natural and they do happen regularly, it takes out our whole electric grid in our country. If the Earth happens to be facing it when it happens, we'd lose our whole electric grid. And that's a real issue, right? That could really happen. So rather than worrying about what might happen, we should worry about things that we know do happen. And guess what? Volcanic eruptions do happen. Wouldn't it be good to study earthquakes, and instead of spending money on something that might be a problem, why don't we spend it on something we know matters? And guess what? I always used to say, because I was modeling Ebola with my students, why don't we spend our money on pandemics? Why don't we spend time developing new vaccines? Why don't we spend, and boy, oh boy, was I a prophet. Because it sure would have been nice if this year, instead of spending all that ton of money on something that's completely not worth worrying about, What if we had spent that on putting together systems for tracking epidemics, or putting together, better vaccines or better ways of developing vaccines? Wouldn't that have been a better spending of our money? I bet you everybody would agree with that this year. So I've been saying that for 20 years. Or what about, let's put money into figuring out how to not have world wars, or let's figure out how to stop the ice age, or the killer bees, or maybe an alien invasion. Well, maybe not an alien invasion. Okay, but those are the things we know do happen. So if you're going to use the precautionary principle, use it for things that do happen, not for the things that might happen. And then you might be able to make a good argument. Besides, giving more power to the government is usually a really, really bad idea. And climate change is one of those things that's a huge power grab. And it's their excuse to intrude on every part of your life. So, and how's that COVID working out for you? Don't you love it when the government is intruding in every part of your life? And people say, well, don't you care about the environment? Yeah, I care about the environment. I'm an environmentalist. I climb mountains. This is me up climbing in the mountains. And I love climbing. And my wife is also, we're environmentalists. Of course I love the environment. Nobody likes dirty air. So let's be wise stewards. Let's be wise stewards, and let's learn from history and scientific methodology, not from the media and politicians. So anyway, so you want to help the environment? Plant a tree. How about that for summing it up?
Thank you very much, Dr. Frank. Thank you for joining Empower You. It's been a spirited, fast-moving, fun time, and it's just always so great to see you. And
likewise, Dan.
Thanks for joining us, and we'll look forward to talking to you again. And just a couple quick things we've got before we need to
sure.
finish up. Dr. Frank, would you stop the share on your
Yeah,
screen?
I'm working on it right there.
Yeah,
boom. Okay, I just did.
It's always fun. So everyone, just a couple things that a couple people have asked about tonight I want to share with you. The first thing is the data. Watch for the data on Follow the Data with Dr. Frank. He'll post some charts for you, Christopher, the many of you who asked tonight, and we'll look forward to that. Somebody made the comment on online about the new CEO of Parler is the former, I don't know, still acting CEO of Convention of States, which is going to be presenting Tuesday night. That is a true statement. Mary, who suggested that she was disappointed in our technical team because she was not able to cast the session with Dr. Frank to her family room with her husband. Mary, that is a great idea. I love the ability to use AirPlay. So we'll start looking at that. Myron S., we're pleased to let you know that you are the winner of the 1-year VIP subscription to Town Hall. To those of you who can help me with the letter that I'm sending out about the school situation, please do. I want to just take a minute to award an Empowered Citizen Award to a very, very, very important man. We are going to award tonight an Empowered Citizen Award to Bob Doolin. This is Bob on his 103rd birthday. Woo! Yeah, I guess. He turns 104 on March 21st. Bob grew up in Price Hill, attended Holy Family Grade School, and graduated from St. X High. He attended the University of Cincinnati, graduated with a degree in civil engineering. While training in Kansas, he met a girl who would become his wife for 70 years. He enlisted in the Army Air Corps in 1941, and after washing out of pilot training, he served as a B-17 navigator with the 8th Air Force 92nd Bomb Group, 326 Bomb Squadron. He rose to the rank of first lieutenant. His unit went to England, where he flew missions over Germany. He was on his 13th mission in 1943 when his B-17 was shot and forced to land in a field in Holland. Can you imagine this? Members of the crew who were able left the plane in groups of 2 and scattered. The first night, Bob and his companion were able to stay in a Dutch farmer's barn where they were given civilian clothing. He had one thing that he treasured dearly, and that was his St. X ring. He gave it to a farmer because it would be a dead giveaway that he was an American. After spending 21 days attempting to escape to Holland with the help of the Dutch underground, Bob was captured along with his pilot by the Gestapo. He was questioned and put in prison for several days. He was then sent to a POW camp by the Luftwaffe, the German Air Force, where he was kept at Stalag Luft 3 for 2 years. PO camp that was made famous in The Great Escape. and another Empower You session later in the semester. As the Allied Air Forces advanced in January 1945, Bob and other prisoners were marched to another camp where they were liberated by George Patton's Third Army. What a story. He returned home to Cincinnati, where he and his wife raised a son and 2 daughters. He served 25 years as a scoutmaster. He has been a member of the Choralers at Dunham and has various presentations for the Life Learn program. In November 2017, at the young age of 100, Bob told us his story to just an incredible event that Empower You had in Sharonville. He's a humble man, and he's a man that doesn't feel like, doesn't want to feel like he's a hero, but he is. And I want to ask you to consider doing us a favor. I know I asked you for one thing tonight. I'm hesitant to ask for 2, but this one's more important than mine. And that's to consider sending a birthday card or some kind of card to this incredible hero, Bob Doolin, whose birthday is on the 21st. His website, his address where you can send him a card will be it's on the website right now. Take a minute, 2 minutes tomorrow, jot him a note of encouragement, thank him for his great service to our country. Bob Doolin, I tell you sincerely, you are an empowered citizen. So, hey, great session tonight. My thanks to the great Dr. Frank for joining us.
My pleasure, Dan.
Gray skies, climate change, Dr. Frank. And tonight I tell you to go out and empower you. Thank you.